We're going to look at the second part of our non-renewable energy resources. We talked previously about fossil fuels and what energy is and where it comes from. Today we're going to look at another type of non-renewable energy resource, which is nuclear. It's easy to think of nuclear energy as, to get confused as to whether it's renewable or non-renewable because it's a lot more clean, but clean and renewable are two very different things. Nuclear energy comes from the energy contained within the nucleus of an atom. Those atomic bonds that hold an atom together are 1,000,000 times stronger than chemical bonds. So there's a lot of energy contained within those bonds. In power plants, they usually, not always, but most of the time will use uranium. Uranium is an unstable, it's a very big, heavy atom. If you look on the periodic table, it's down there towards the bottom, right? It's big, heavy, it's unstable, but it's naturally occurring. And through time, uranium will become more stable. It will decay, which is to break apart, and will become more stable. Now, what we are doing in nuclear power plants is making that happen faster. We're making the uranium atoms break apart with fission. So uranium pellets will be put into the tower. The fuel rods will go in and they will bombard them with neutrons. The neutrons will hit the atom and cause it to split apart. That process of splitting is called nuclear fission. And when the atoms undergo fission, they break apart and release that energy. Now, that energy is released usually in the form of heat. And that heat is what starts the reaction to turn that nuclear energy into electrical energy. It also releases other little particles whenever it splits apart. Think like if a firecracker goes off, there's energy and sound and heat and light, but there's also little pieces of the firecracker that are released that float around, the ash and whatnot. So imagine that. You've got little neutrons that are released from one atom breaking apart, and it starts a chain reaction of hitting the next one, and then it breaks and hits the next one, and then it breaks. So here is a look at that process. Here's the neutron coming in. It hits that uranium, and it causes it to split into smaller, more stable atoms. So we're using krypton and barium here. And then it also releases those little particles that then hit another uranium atom and cause it to split and break down. Now, each time you see there's energy released. We are releasing energy. And that energy heats water, and that water is what causes our electricity. So we'll get to that. So around the reactor, there is a cooling fluid that keeps it from getting out of control. They have the fuel rods with the uranium pellets. They're bombarded with neutrons. But if they just let it go out of control, then you would have made a nuclear bomb, basically. So they can't do that. They have to have other rods in there called control rods that absorb the extra neutrons and control that rate of fission. If they want the rate to slow down, then they put the control rods more into the fluid. They immerse them deeper. If they're okay with it ramping up a little bit, they'll take the rods out and let it ramp up. So those control rods will absorb the neutrons and halt or slow down that reaction. So that heat from the reaction is used to heat water. It makes steam, and that steam generates electricity just like a fossil fuel plant. If you notice, this looks very similar to our fossil fuel plants. The only difference is you don't have that mound of coal out here to the side. So instead of burning a fossil fuel, you are undergoing nuclear fission. But after that, it looks very similar. You've got water being heated. The water goes to those fan blades, what we call turbines. The turbines turn. They turn the crankshaft of this generator. The generator is a magnet and a coil of wire. The magnetic field pushes the electrons through that coil of wire, generating an electrical current, and then it's taken to homes and businesses to be used. So second part here looks exactly like a fossil fuel plant. The only difference is how you generate that heat. So it's pretty clean. You see there's water vapor coming out, but there's no other smoke like there would be from a coal power plant or a oil power plant. It's just water. So advantages, it's very clean. It's a very concentrated energy source. You can get as much energy, as much electricity out of a little pellet of uranium. And you see the little picture here, the guy holding it. That's it. You get as much energy out of that thing as you get out of a train car full of coal. So not only is it itself more concentrated, but you don't have to spend as much transportation. And think of transportation, diesel trains, diesel trucks, you're emitting fossil fuels, transporting this stuff too. So less transportation, more concentrated energy source, no greenhouse gases being emitted out of this. It's just water vapor. And then any country that has very limited fossil fuels and limited ability to transport it, they can very easily transport in uranium and get nuclear power. So a lot of your nations that are perhaps landlocked or don't have a lot of natural resources, a lot of space and availability, they can do nuclear. And it also doesn't depend on any kind of weather or sunlight or availability. You just need some space and some water. So why aren't we doing more? I've talked it up so much. Why is this not like what everybody is doing, right? Well, it turns out it's pretty expensive. Nuclear plants cost about $3,000 per kilowatt option. Wind turbines are only about $1,000 per kilowatt, and a gas plant you can put up for $600 a kilowatt. So watt for watt, it's a lot more expensive to build and maintain a safe reactor. There's a lot of concern for safety. Obviously, you're dealing with radioactive elements that can cause some trouble. So the safety protocols are a lot more heightened, and you have to train everybody and have all the safety gear and whatnot. So not just the building itself, but everything that goes into maintaining the building. Waste is radioactive. Even though the uranium has split into smaller, it's still a radioactive element. And to store that waste is very difficult. You can't just toss it in a landfill, right? You have to put it in a place that's geologically stable, so earthquakes can't come and split open and release it, out into the water supply. And right now we don't know what to do with it beyond storing it. We've got a video I'm going to show you on how and where we store nuclear waste, but eventually we're hoping that there will be the option of transmutation, which is kind of like recycling. It's putting the energy back in and using it again, kind of re-enriching that uranium. So that's an option, but still, again, right now it's so expensive. It's not a best option. And then, of course, there's the safety concerns. There's a concept we'll talk about a lot when we talk about pollution, which is NIMBY, not in my backyard. Everyone loves the idea of nuclear, but do you want a nuclear plant right in your backyard? Not really, right? We have these thoughts of these nuclear plants that have not worked out very well, such as Chernobyl in Ukraine, where they released radioactive materials into the air, and it basically made the entire area inhospitable. Right now you can go and tour, but they really don't recommend you be there long because of all the radioactive materials in that area. But that was a long time ago, and it was in Ukraine, and they have updated safety regulations. But even still, there's that fear in the back of people's minds. In Pennsylvania, 3 Mile Island is another one you may have heard about, where they had broken pumps, and that released a small amount of gas, but still, even a small amount of gas is terrifying to some people. And then, of course, more recently in 2011, the tsunami in Japan, they had a nuclear meltdown with the Fukushima reactor because of the tsunami and the earthquake and whatnot. It got out of control. But of course, since then, we have had additional safety requirements. Things have improved, but still they're fighting a PR battle big time. People are not wanting it because of these concerns, which are legitimate concerns, even though there's only 3 examples that we cited out of the thousands of plants that are out there. Still, they're fighting a PR battle there. So we're going to look at a video together of a tour of a nuclear power plant, and we'll discuss more about nuclear energy and whatnot. So stop here, and we will discuss together.